Hey JJ, I'm going to attempt to explain some stuff from 8.3 and 8.4 to hopefully kind of set you on the right track. My goal is that maybe if you get those both done by Monday, then I can give you and Gwen your guys' Chapter 8 quizzes, which instead of, I've been kind of grading homework, but it's mainly been more for completion. I'll actually grade every single problem on the quiz and kind of give you guys feedback like I normally would, and you guys can do reworks on them, and then we'll be ready for test and all that good stuff. So, basically, here's what you need to know. This section's about multiplying and dividing trig numbers. But basically, I want you to know that trig numbers, again, are just a different form of imaginary numbers on a graph. So, for instance, I realized number 2 is longhand, but just to do something like number 2, oh wait, you know what, I'll do number 1 so that I'm doing things that, I didn't, didn't assign here. Okay. So number 1 is 3 cosine 20 I sine 20, and I'm just going to write 3 cis 20, right, times 4 cis 30. To multiply trig numbers, it's really, really easy. You literally just multiply the outside, so multiply those and get 12. But you add these. Okay, cis 50. So that's what that is, alright? You might be like, well, that's pretty easy. And actually, when you get down to things like 33, which is division, it is literally the exact same thing. So the section of 1 through 6 and 33 through 38 are so easy, because 33 again is written in longhand, but it's essentially 20 cis 75 on top, right? Cosine 75 plus I sine 75 is just longhand for that. And then the bottom is 5 cis 40. And division is you divide the front numbers, we get 4, and you subtract these numbers, and you'd get 35, right? Now the main thing is, though, knowing how that works, which is actually what, sections with numbers 7 through 16 are about, and 39 through 46 are about, so we'll do one of each of those, alright, so you can see those, and kind of see where we're at here. Alright, so, why don't we just do number 7? If we've got to do one more of those, that's fine too, but I'm just going to do number 7. So basically, why does this multiplication thing work? When you've got two numbers that are in trig form, or in cis form, why does it work that you can just multiply the outsides and then add the angles or the degrees, and you get the answer? So that's actually kind of what questions like number 7, 9, those sorts of things are trying to get you to do. You know what, number 9's a little bit harder, so why don't we do that one just for the heck of it? Because number 9, it says find the product z1, z2 at a standard form. Then it says write z1, z2 in trig form and find their product again. Finally convert the answer that is in trig form to standard form to show the two products are equal. Basically it's saying, if you've got these two numbers, so here's number z1 is what it's called. You've got 1 plus I root 3. And then the second number is negative root 3 plus I. Alright? They're saying let's multiply these in standard form first. Sorry, my board's a little wobbly today. And then multiply them, turn them into trig form and multiply them, and essentially make sure they're the same thing. So here we go. If we multiply these old school, alright, that literally just means what we would have done the very first section, which is actually, that's supposed to be root 3. What we would have done the very first section, which was just foiling and doing our thing from alg 2. Okay, so this technically step is different. This is basically just saying multiply old school way. Alright, is essentially what's going on. So we're going to FOIL. 1 times root 3 is negative root 3. 1 times I is 1I. I root 3 times negative root 3 is negative 3I, right? Because root 3 times root 3 is 3, negative 3I. And then I times I and root 3 is plus root 3I squared. But you did a perfect job remembering the I squared becomes a negative, And so now we actually can combine these. So negative 2 root 3 is our real part, and 1i minus 3i is negative 2i. Alright? So hold on to this thought. Okay, this is our answer from multiplying the old school way. Alright, I'm going to put this up in the corner, because I'm probably going to have to erase. Okay, so if we just FOIL these imaginary numbers, boom, that is what we get. Now, trig multiplication is really, really easy. We just saw, if it's in cis form, you multiply the outsides and you add the insides. But the annoying part is actually changing things into trig form is really what's annoying. But we can do that using our equations from last time. So I gotta rewrite this, sorry. So this is root 3 plus I. So if I were to rewrite this in trig form, I kind of have to remember that this is your x and this is your y, right? You remember how x squared plus y squared equals r squared, right? It kind of comes down to some of those things from polar again, but basically, to find the magnitude, right, because this is going to be cis, we got to have the radius, right, or the hypotenuse goes here, and the degree goes here, right? And I could either draw this out or do it kind of the long way. If I draw it out, it's like it goes 1 this way and root 3 up. I already recognize what type of triangle that is, right? 1, root 3, 2. But in case you're like, oh, what do? You just do the Pythagorean theorem, right? 1 squared plus root 3 squared equals c squared or r squared or whatever. 1 plus 3 is 4, square root that and you get 2. So I know this is a 1 root 3, 2, which is a 60-degree triangle. Boom. This thing is the same as this, right? That's what we did last section. That was 8.2, was turning these things into trig numbers, right? And we're doing it so that we can actually multiply them. Because multiplying these is going to be super, super easy. And we're going to see if it matches this. Alright, so now same thing here, except for this is negative root 3 plus 1i, right? There's an invisible 1 there. So this is actually still going to have a magnitude of 2, because negative root 3 squared is 3, plus 1 squared is 1. So that's still 4 squared root is 2. So this is 2 cis. The other way that I could figure this out is draw it again, right? If I go negative root 3 this way, and then I go up 1, this is another 30, 60, 90. It just happens to be 30 away from 180, so it's 150. Right? Is that okay? Boom. I don't know why I'm asking that's okay, because you can't, hear me, but that's fine. So now, if I go ahead and multiply these the way that I just showed you, you just take 2 times 2, which is 4. And you just do 60 plus 150, which is what, 210? Yeah. Now the question is this the same thing as the answer we already got, the negative 2 root 3 minus 2i? That's the question. They wanted you to convert this into this form to c, right? Well, in order to do that, you just got to be like, oh, well, let me draw a triangle here quick. Hopefully this is still on the screen. Let me double check and make sure that's still on the screen. Oh, yeah, we're still on the screen. Great. Okay. So that means if we draw 210 degrees, which is right here, and we draw a hypotenuse of 4, we got to figure out these two sides of the triangle, because it's going to be this and this eye. No, this and this eye, right? Well, 210, this is half, right? So this is 2, and this is 2 root 3. But it just so happens they're both negative, so it'd be negative 2 root 3 minus 2i. Boom, they are the same, check mark, right? So that's what this section is all about. It's really basically to show you that multiplying these is so much easier than foiling these and doing this, which is why things are so nice when they're in trig form. Sometimes they're not necessarily in trig form, though, right? So let's do a division one so you can kind of see the same thing. I do realize I'm bopping around a little bit, right? I talked about 1 through 6 and 33 through 38 first, because those are so easy. They're just the trig forms. And then I just talked about, this is in the section 7 through 16. I'm about to do 39 through 46, because that's multiplying and dividing and seeing that it works out and that you can do them both ways. This is kind of why it works. And then I haven't talked about de Moivre's theorem yet. Okay, so I do realize that. So let's do a division one, though. So let's hop down. And de Moivre is what actually helps us with section 8.4. That's what helps us with that. Okay. So let's do number 43. Wow, I just That's what wrote into my title. Great job. 43. Z1 is 4 plus 4i. Z2 is 2 minus 2i. Alright, so the first thing we got to do is we've got to do division old school, right, which I really don't like, but you should be good at it because you were a pro at the first section and it's algebra. So it's where you got to do 4 plus 4i divided by 2 minus 2i. And how do we have to do that? We got to do that using conjugates, right? We got to do this thing. So you're a pro at this. We do 2 plus 2i, 2 plus 2i, and we do a whole lot of foiling. So 4 times 2 is 8, plus 8i, plus 8i, plus 8i squared. And that's going to go away and change into a negative when we get there. The bottom is 4 minus 4i plus 4i minus 4i squared. And that'll go away and turn into a plus, and these go away. So then on top I'm going to have, that's weird, these go away, right? And I have 16i over 8. Usually that's not that convenient, but that just goes down to 2i. Interesting. So boom, that is these divided old school, right? So I'm going to keep my answer up here, right? 2i. Because again, the directions on this say find the quotient in standard form. So that's what we just did. We did it the old school way. Then it's saying write these two things in trig form and find their quotient. And then convert our answer from trig form to standard form and make sure it makes sense. So we did the long way, which actually wasn't that painful because we didn't get any fractions, everything canceled. That was really nice. So now we go to trig form. So we've got to go to either a graph or doing Pythagorean theorem, right? 4 squared plus 4 squared equals c squared, which is 16 plus 16, 32. Square root of 32, that's going to be 4 root 2, right? 4, 4, 2, 2, 2, 2. And the other way I can know that is if I went 4 plus 4i, it'd be 4 plus 4i. So 4 this way and 4 up. And I go, oh, 4, 4, 4 root 2. This is a 45-degree triangle, right? And remember, if you don't know what degree it is, you can always do tan inverse of 4 over 4, and you get 45. But you probably recognize that these are that ones. If they give you ones that are decimals, which I actually don't think they do. I think they're nice enough to make them like 30, 60, 90s or things. But if they did, then you could do tan inverse of the y over the x, and you could get the degree, even if it wasn't a nice one. So this one is actually 4 root 2 cis 45, right? That's this one in trig form. This one, as soon as I see duplicate numbers, I know it's going to be some sort of 45, right? This one just happens to go positive 2 and then down 2, right here. So I know it's a 45 here. But we can't have negative degrees, right, in cis form. We can only have stuff between 0 and 360. So that's 315. So this is going to be 2 root 2 cis 315. Right, so that is that. And again, you can do Pythagorean theorem, but I know 2 root 2. So now we have to divide them, right, to see what we get. So let's divide. So we're going to have 4 root 2 cis 45 divided by 2 root 2 cis 315. This is where you do have to be a little bit careful and abide by those rules, like I said, that you got to be in between 0 and 360. So here, these cancel, and 4 divided by 2 is 2. So 4 root 2 divided by 2 root 2 is just 2. We divide those, then we subtract these. So 45 minus 315 is actually negative 270, right? I'm thinking so. Yeah. But remember, we can't have a negative in here. So negative 270 would be like going this way all the way around here. But what's negative 270 equivalent to? It's equivalent to 90. So 2 cis 90 is actually our final answer for this part. Now the question again is, does that match our answer of 2i? Right, well if we took this to standard form, I didn't do this last time, but the other way to take it to standard form, and we could have done that with the other one, is just to write it out long form again, right? To do 2 cis cosine, 90 plus I sine 90, right? That's the long form of this. And cosine of 90 is 0. Should have 0 plus sine of 90 is 1. So 2 times 1i is 2i, and that is that check mark, right? So what we just did was we just proved that multiplication and division do work. That's the rules for them, and it's because it all relates back to what's actually going on in, you know, the real and imaginary axis plane. So that's the bulk of section 8.3, but there is one more thing called de Moivre's theorem, which actually is just kind of like an additional part of multiplication, really. So de Moivre's theorem big guy's name, but basically his theorem is saying that if you've got a cis number, I'm going to like do number 17, but I'm going to do it in cis form. So instead of writing 2 cosine 10 plus I sine 10, I'm just going to do 2 cis 10. Right, saying that this thing is to the 6th power. Well, basically de Moivre's theorem is saying that you can essentially put this 2 to the 6th and then take 10 times 6. So it'll become, I believe that's 64. Cis 60 would be your final answer to that. The reason this works, though, is if you think about it, this is 2 cis 60 written out 6 times, right, which I'm not going to do. But if you wrote it out 6 times, multiplication says you take the 2 times the 2 times the 2 times 2 times 2 times 2, which is 2 to the 6th, and you take 10 plus 10 plus 10 plus 10 plus 10 plus 10, which is 60, right? So de Moivre's theorem says take the number to the power, and then take the number times the angle, and you get that. So that's how you do those. And then, for instance, I want to jump down and do one of the really hard ones, like maybe like 47, so you can kind of see how those work. But essentially you could do the same thing that we just did with multiplication and division with stuff like 27, right? So 27 says something like negative root 3 plus I to the 4th. And in this case, though, it doesn't want you to do it both ways, because I don't know about you, but I don't want to FOIL this out 4 times. That would be awful. So it's just saying change this into cis form, right? And as soon as you change that into cis form, then you can just take the number to the 4th power and the angle times 4, right? So the section of 17, number 17 through 32, they want you to do them all by de Moivre's theorem, which is just taking this to the power of that and then taking this times that thing, not to the power of it. So do those like that as well. Okay, do not do stuff like 23 through 32 the long way. Okay, don't do that. The only ones they want you to do like both ways, like doing it the old school way and the other way, are like what I already showed you, 7 through 16 for multiplication and 39 through 46 for division. But then I give you a couple at the end of the assignment that are kind of tough ones, but they're not horrible, because basically it's all about using trig form to your advantage. Okay, so they even give you a hint here. They're like, write all numbers in trig form. And then do the problem, and then convert it to standard form. So basically what they're saying is, there should be one in there, sorry, don't FOIL this 4 times, and then take it times this thing after you FOIL it 4 times, and then divide long ways by this. They're saying, change all these into trig form, then do your multiplication division, which will be really, really easy in trig form, and then you can put your answer back in standard form. So this is my first culprit. 1 plus 1i is 1 and 1. So 1, 1, this is root 2, this is a 45, right? So this is just root 2 cis 45. And you will get faster at changing these into trig form. It just comes with the course here. So 1, 1, root 2, and that's a 45-degree triangle. 2i to the 2 is a little bit weird. That's where you got to recognize, oh, I don't go anywhere in the real axis. I just go up 2, right? So this is actually 2 cis 90. If you were like, man, I didn't recognize that, it's just basically like it's 0 squared plus 2 squared equals c squared. So that's 4. So obviously c is going to equal 2. So we know it's 2 cis something. And then to figure out what degree it is, oh, sorry, it should be the second degree, should be the inside, is you just would have to take, tan inverse of 2 over 0, which is undefined. You're like, oh, wow, that's crazy. But then you'd have to recognize, oh, 2i is just up on the axis. It's 90 degrees. If it was negative 2i, it'd be 270 degrees. And then down here is negative 2 root 2 plus 2i. We did one similar to that. Actually, is this the same one? No, we got to do negative 2 first, then up 2i. So it's this one. So it's not down here, it's up here. So this is 2, 2, negative 2, 2. So this is 2 root 2, and it's a 45, but it's in this quadrant. So this is 2 root 2 cis, what do we got? 135 is what I said, right? And there's no powers on that one? Doesn't look like it. Okay, so now we just have to do the math here using the theorems that we have. So I'm going to do the powers first, right? So de Moivre's theorem says I can take root 2 to the 4th. So root 2 times root 2 is 2. And another root 2 times root 2 is 2. So 2 times 2 is 4. So root 2 to the 4 is 4. So this is 4 cis. And I got to take 45 times 4. 45 times 4 is 180. So that's that one. And then I got to take these powers here. I did realize that it might have just been easier to square this one because we don't have to FOIL it, but we're just putting them all in cis form. So 2 squared is 4. And then 90 times 2 is 180. So 4 cis 180. Wow, those are identical. That's crazy. And then this is still 2 root 2 cis 135. Now we add the tops. Well, we multiply the 4 times 4. So 4 times 4 is 16 cis. And add the tops, we get 360. Right, we're going to be dividing by 2 root 2. Cis 135. Honestly, this one is going to be easier to subtract these, because dividing these, I can reduce this to 8 and 1, but I'm going to have 8 over root 2, which means I need to get the root 2 out of the bottom. So I'm going to have 8 root 2 over 2, which is 4 root 2. That's gross. So dividing those, you get 4 root 2, cis, and 360 minus 135 should be 225. So 4 root 2 cis 225 is the answer, but they want that in standard form. Well, I'll just come over here because I'm out of room, right? But 4 root 2 cis 225 is down here, and this is 4 root 2. So I'm going to recognize, oh, that's a 45-degree triangle, obviously. So it's 4, 4, 4 root 2. But these are both negative. So it's negative 4 minus 4i is the actual final answer there. You know what? I decided I'm going to stop this video and restart because I feel like I did a great job on section 8.3. And then if I do something stupid on 8.4, I can just restart that one instead of doing this one. But there is a video on 8.3. Let me know if you got any other questions.